Good morning. My name is Cam. I am here today with Rahul Jadhav, and he is going to be talking about securing Kubernetes with AccuKnox. I had the pleasure of meeting Nat, one of the co-founders, along with Rahul, a couple of months ago, and was really impressed with AccuKnox. Love their open source roots. They are based a lot on KubeArmor. And, a little bit about myself. I work in cybersecurity. I help run the cybersecurity division at Dido. We're a Google preferred partner, and we're also the Google Security Partner of the Year and preferred for authorizations to operate in both the FedRAMP and the DoD space. Very proud of our work. We do cyber for cyber firms. And, one of the things when we're doing cybersecurity is we really work a lot on automation. Automation is really key for cybersecurity, and that's what brings us today to talk about AccuKnox and securing Kubernetes. So Rahul is a co-founder of AccuKnox. He leads their engineering and open source software team. So Rahul, what's your elevator pitch? Do you want to give us an introduction to AccuKnox?
Absolutely. At AccuKnox, the primary problem that we are trying to solve is how do you make sure that you can deal with the zero trust security? How do you make sure that the zero trust security is accessible to general workloads? When it comes to zero trust security, how do you make sure that you understand what your workloads are doing and then come up with a least permissive security posture for those workloads? And essentially, that's the context in which some of the open source work that we have done plays a pivotal role. Let's talk about that, shall we?
Sure.
So just to provide you some background about how it all started, so sometime in 2019 we were thinking about we were looking at MITRE Attack TTPs, and within those TTPs
hold on a
we
second.
found that
What's a TTP for our audience?
It's tactics, techniques, and procedures. So what happens is the MITRE Attack framework gives you a way to envisage what an attacker would do within your workloads, right? So it gives you a set of tactics, techniques, and procedures that an attacker would typically use in the context of your workloads. So you can think from the defense perspective. So it's mentioned that an attacker will typically, let's say, for example, try to subvert the trust controls by installing the root certificate. Now, what would be the mitigation actions in that context? So one mitigation action that one could follow is do not allow anyone to write into the root certificates folder. Do not allow anyone to update the root certificates folder. A very simple mitigation rule. But what we found is that there was none of the tooling that existed would allow someone to do something like that kind of basic remediation.
Perfect. Okay.
So
that's a great explanation. That's exactly what I was looking for. Thank you.
Thank you. So that's how it all started from. That was the problem statement that we began with. And then when we started working on it, when we looked at some of the runtime security tooling that existed in the context, some of the open source runtime security tooling that existed, most of it was focused on either network security or service mesh and the likes. But if you look at MITRE TTP frameworks, and this is a screenshot that I've taken, the above section essentially shows in the context of network, what are the TTPs? So these are the tactics, these are the techniques, and every technique might then have several procedures. For example, in the context of modify system image, there are two procedures that are available. So tactics, techniques, and procedures. When it comes to systems controls, you can see that there are a lot more tactics that are available as an attacker for myself. So you might want to think from those perspectives as well as when you're trying to think from the defense perspective.
Excellent. So why did you choose open source software? Like, why did you start working with KubeArmor?
Yeah, that's a great question. When we began our journey, we wanted to make sure that we get the approach right, because essentially what we saw was there are multiple approaches that were possible, and we decided to take an approach of using Linux security modules. Now, one advantage with open source and being into CNCF, we decided right from beginning that we want to make sure that we talk to the industry forums to the security experts, show the approach, because approach is, in my opinion, approach is everything when it comes to security. You take a bad approach, your attackers, the attackers can easily, you don't want to have a false sense of security. Right? That was the primary.
Yeah, and I think the automation you bring is an important part of being a good process because, but that leads to another question. So, AccuKnox is a commercial product, but what does somebody get by buying AccuKnox instead of using KubeArmor? So, the open source.
Like you mentioned, the whole automation. You have a zero trust. I talked about zero trust security posture, understanding the application behavior, and then coming up with the least permissive security posture. That is not a one-time thing, right? It's not a one-time. It's not a flag day event, so to speak. It's a continuous. So your application developers are continuously changing the applications. One of the advantages that you get moving to a cloud native workloads is that you have very agile development cycles, but with that you have all the security risks. Right? So our intention with AccuKnox is that we should be able to make sure that we provide the right automation to the user, such that when the application is updated, your security posture changes in sync with the application update. The zero trust security posture is maintained over a period of, is maintained along with the application process. So that is one. Multi-cluster security orchestration, having a single pane of glass, channel integration, all of those aspects come with AccuKnox. So basically, simplification is the theme when it comes to enterprise proposition. The core policy enforcement and telemetry and visibility is available right in the KubeArmor itself, which is the open source. And let me just clarify one more thing, that we do not maintain an upstream fork of KubeArmor. We use the same KubeArmor that is out there in open source, even in the enterprise, but there are additional toolings that are built on top of KubeArmor, which is there in the AccuKnox enterprise.
Yeah, that's one of the reasons I really liked your product. I'm a big fan of open source, but sometimes having tooling around it and expertise and offering that consulting is totally worth the value. So excellent. All right. Well, I know you're going into runtime security next, so please keep going with the slides.
Yeah. So runtime security, again, this is something that we chose, even though as an enterprise security solution, we have targeted all the three dimensions, right from the static to the admission time to the runtime. But we found that runtime is where the final, most of the attacks gets manifested. So you need some sort of defense mechanisms at runtime. All the zero-day attacks, they are going to get manifested once the workloads are actually deployed, and the command injection attacks, ransomware attacks. And I'll give an example of how the tooling can help you in the context. But coming back to the original point, most of the runtime solutions that we checked in the context, they were great. They're great solutions, but they were primarily from the observability backend. So they were primarily observability or monitoring tools. And then in response to those observability or monitoring events, you can then take some remedial policy action. That could be killing the process or deleting the pod or cording of the node. Those were not truly enforcement engines, because essentially it cannot stop the attacker before the attack has actually happened. That was our primary aim with KubeArmor. Like I said, post-attack exploit mitigation, which is a term typically used where you take a remedial action once you detect some malicious activity or suspicious activity. If you do post-exploit mitigation, it basically provides a false sense of security, because now the attacker has been able to execute its code in the actual workloads, which means that the attacker was in a position to actually turn off the security knobs. They can fiddle with access logs by the time you take a remedial action. So you could go and kill the process, you can go and delete the pod, but by the time you do that, the attacker might have already changed some of the state within your workloads, which means they might either become incognito or your access logs might not show what the attacker did. So this is where we started off. We thought that having post-exploit mitigation is a flawed technique. We want to bring in architectural elements wherein even before the access is attempted or a process is formed, we should be in a position to stop. And that's where some of the architectural elements that we have chosen for KubeArmor comes into play. If you see two things that KubeArmor does. One, it integrates, it couples very well with the Kubernetes native architecture. So most of the policies are orchestrated using Kubernetes CRDs, custom resource definitions. We have eBPF components, which gives you application behavior analysis or observability. And in response to those events, we create something called as security posture. And those security posture is essentially enforced using something called as LSMs, Linux security modules. LSMs have been in use for past couple of decades, but they're extremely difficult to use. And that was one of the problem statement that KubeArmor decided to tackle. How do we make sure that LSMs can really be consumed by users without having to deal with the complexities of maintaining the policy constructs, which are in the context of AppArmor SLNS. Anyone who has used AppArmor SLNS knows how difficult it is to use. So we wanted to, and then there are new LSMs that have sprung up, which are extremely flexible, but that requires one to write EBP of bytecode to do policy enforcement. So all this complexity of doing runtime security was something that we had in mind. We wanted to make sure that it is we have a cloud native architecture in place, and that's how KubeArmor's architectural elements were put in place.
Very cool. Well, I know you have some more slides about LSM. Do you want to go over those? And then I'd like to maybe hear something about some use cases, and then maybe do a live demo.
Absolutely. So, like I said, abstracting LSMs was one of our primary goals. We wanted to make sure that we don't end up introducing a new kernel primitive or something like that, because usually introducing a new primitive takes several years to get matured. So our intention was to abstract existing LSMs. You see a sample policy here. That sample policy in turn gets orchestrated using Kubernetes. And when KubeArmor receives that policy, it then enforces that policy using existing LSMs, and then it converts it into the corresponding format. In the case of AppArmor, this is the AppArmor policy. In the case of SLNX, it will be listed in a CI, Common Intermediate Language format. In the case of BPF LSM, it will be BPF bytecode. So all that complexity is essentially under them. This is another important point. Like I said before, if you want to have asynchronous control, policy remediation in response to suspicious activity, that's one way to go, but that's going to provide you a false sense of security. With LSMs, essentially, what you get is inline controls. You see LSM hooks are native to Linux kernel. You can take a policy decision when the execution is happening. So is the fork allowed? You can take a policy decision that as an inline control. So it's really flexible. It's really powerful. And that's why we ended up selecting LSM as an approach.
Very cool. All right. Well, what are some use cases of KubeArmor? More of AccuKnox.
Actually, here is some set of sample demo policies. Very simple policies, as you can see. First of all of these are Kubernetes orchestrated resources. Here, the sample policy says that I want to audit access into /model in MySQL. This is where all the raw tables for MySQL are kept. So I want to audit access into this. Only any process that modifies anything into this, I want to audit it. But this is not the key feature. Action block. So here you see that we have the ability to actually block the action in the first place. So here the rule says that block access to service account token altogether. A lot of times what happens is
LSM instead of post incident, you're stopping it before it even starts.
Exactly. So if someone tries to access the service account token, they won't be able to get the token file at all. A lot of times what happens is Kubernetes by default mounts the service account token as part of the pod initialization. And no process within the pod uses it, but still the service account token is available there. One of the first or second or third step for an attacker would be to go and check the service account token and use that to do lateral. So all that is thwarted using a simple rule such as this. So this is an interesting rule. This particular policy, it shows that how do you block process executions. Very simple. You have dynamic package management tools. You want to deny execution of those. So very sequence. All of these eventually map to some sort of MITRE Attack TTPs, and that's what the mapping here talks about. Lateral movements or credential access or execution. So this is a sample demo.
And I know you keep mentioning MITRE Attack, but you guys also followed the Kubernetes hardening guide from CISA and the NSA, correct?
Yes. So the Kubernetes hardening guide, in fact, STIGs, PCI DSS, CIS benchmarks, all of these are available in the form of policy templates. There is a CLI tool, and in the enterprise version, you automatically you get the discovered set of hardening policies in the context of this thing. Maybe I can now give a quick tour as to how the actual system works in practice.
So, I usually say never do a live demo, never work with children, never work with pets. But yeah, please, love to see a live demo of it.
Yeah. So the demo that I have here is essentially HashiCorp Vault, and any organization which is of any decent size would be doing secrets management, right? Anyone within AccuKnox as well, we have to handle secrets for all the microservices and databases and things like that. So what HashiCorp does is it keeps all the customer secrets within a particular volume mount point, and that volume mount point is typically accessed by a single process, which is bin vault. But the nature of Kubernetes pods allows that any binary which is part of that particular pod has direct access to these volume mount points, because you can't really control access at a process level. That's what changes. Essentially, this volume mount points where the secrets are stored are attackers, ransomware attackers' sweet spot. If the attacker manages to get inside the vault pod, the attacker can encrypt the secrets and then essentially call for ransom. One more important point that I need to make is it's not necessary that the vault itself is insecure. You might have other microservices which might be insecure, and using those microservices, one can do a lateral movement into vault and inject the commands. Right? It can be command injection attacks, and then a new command is new binary is available, which will then go and encrypt the volume. So this is something that needs to be protected. Very simple. So what KubeArmor does is, even if someone, first of all, it won't allow anyone to create a new binary altogether within the pod. Even if a binary is introduced somehow, or if it's an existing binary, let's say, for example, tar or zip, which is already present within a container image, that binary won't be allowed access to the volume mount point. So essentially, you will see a rule. You have a rule which says that only allow bin vault to access this volume mount, and it looks something like this. Here it shows that only allow access to /vault directory for /bin vault process. Only allow these processes to execute within the vault pod. Everything else gets blocked. No other binary would be allowed to access /vault. Very simple policy. It's less than 10 lines, but that gives you enough protection such that you cannot have ransomware. So this is this is something that I would like to show using an actual demo.
Sure.
I would like to just quickly show you how the interface looks like. So this is the AccuKnox enterprise version. Here I've selected a particular cluster, which is Oracle EVK 7, and I've selected the namespace vault. And in the namespace vault, you see all the policies that are already auto-discovered. There is a vault protect policy, and the vault protect policy is something very similar to what I've shown in the example there. Right? Currently, it's inactive. So I am able to access this particular vault engine. I have a set of secrets here. I have Docker access token, and I can access it. So this is a very simple example. What I'm going to do next is I'm going to show an attack. Like I'm going to exec into the pod, vault pod, and then show that you won't have access to this, secrets anymore. So I am already inside the pod here. So this is a Kubernetes cluster. You can see Vault deployed here. I'm going to exec into the Vault. This is the folder where Vault keeps all its data. And this is the volume output /Vault data. Now, if I simply do a logic, if I move some of the folders, right? I'm going to just move some of the folders.
So you're acting as an attacker right now. You're damaging the folders. Okay.
Yes, I'm attacking. I'm acting as an attacker and damaging the folders. So now what happens is it shows that no secrets in this bag. You see, all the secrets are now not available. Essentially, as an attacker, I'm able to. I can delete. I can do anything here.
All right, and thank you guys for joining this demo. We're done. I guess.
So that's a manifestation of attack. Now let's see how AccuKnox can protect you. Let me just revert back the corresponding folder.
And we wish an attack was that easy to revert. Usually it's a lot worse. So.
Exactly. So I'm just moving the folder here, but the attacker can encrypt the folder with the password and then demand for so now next I'm going to do is apply this particular policy. So the policy is usually going through management. You might have one person who might apply the policy, another person who might have to approve the policy. So I have both the approval as well. So right now the policy is activated. You can see the policy is active right now. Now,
but you would normally have a principle of least privilege. You would have the ability of separation of duties, etc. But for the demo, at least, you are acting in all the roles right now. Okay.
Yeah.
But the policy is in there now. All right.
Yes,
and now
the policy is now here.
Yeah. And you're going to go back to the role of evil Rahul, and you're going to attack the system, right?
Yes. So now I'm going to so here now I try to move the logical temp. The permission is denied for me. So anything. So I try to execute any other binary. The permission is going to be denied. But at the same time, you can see the Vault will continue working. The only binaries that are allowed are the binaries that are allowed as per this policy. So only these binaries will be allowed to be executed, Vault and BusyBox, and only bin Vault will be allowed access to /Vault. So now anyone who tries
audience can, sorry. Anybody who tries to access, go on. Yeah.
So what I'm trying to do here is to even trying to list the files. I won't be as a root user. I won't be in a position to even list the files. But if I go somewhere else, I can list the files here. But I can't list the files as /Vault /data folder.
Yeah. And for me, this is just the key of why I liked AccuKnox. It's built on open source. You can still do all this at the same time. You've got the ability to automate your runtime protection profiles. And really, this is going to stop, unknown zero-day attacks, because you don't care whether or not the binary can do something, whether or not even an elevated privilege user is stopped by the policy because it's a coordination of the LSM and you're not installing new security modules. They're already vetted. You're just doing configuration of 3 well-vetted Linux security modules so that you have this orchestrated, very strong security that can stop, like I said, even future zero-day attacks. All right. Well, thank you so much. Did you have anything else you wanted to demo?
No, quickly. So, like I said, the actual policy is a Kubernetes orchestrated resource. So you can see that the policy was applied 90 seconds before. And all the other important part is how do you get remedial information? Like, how do you, if there is an attack, you need to know what are the violations that have happened, right? So here you can see that the Vault access violation has been prevented here. So not only is it about the policy enforcement, but once the policy is violated, you need to get a violation information, and that violation, the alerts that you get, you should be in a position to stream those alerts to the SIM tools. All of those capabilities are available in the enterprise version. KubeArmor does basic enforcement. You have a policy, it can enforce it, but you want advanced channel integrations and all of those things. That is something that is provided in the enterprise version.
Very neat. All right. Do you want to go back to the slides? Yeah.
Yeah.
I don't know if you want to do presentation mode again.
Yeah. Here I go. I hope it doesn't go to the first slide. Yeah. Yeah. That's good.
No worries. All right. So Please,
And
I was just going to say, continue along.
Yeah, so I was going to say that doing this consistently across all platforms is very important. We started off with GKE cost, container optimized OS. That's where we started building off with, because container optimized OS is a hardened distribution. It's if you have the right approach, if you have the right deployment mode, you should be able to operate with hardened distributions as well. So GKE is something like GKE costs, which does not allow you to install anything at the host level. So KubeArmor does not require you to install anything at the worker node level. It installs itself as a pod, as a daemon set pod, but it does not require you to insert any rule or change anything at the worker node level. So and you get the same across all the platforms. Another interesting thing is, using the same information, we can actually do network segmentation as well. KubeArmor has information into what the workloads are doing, including the system calls. Based on that, we can get a communication graph of all the microservices, and then auto discover the Kubernetes network policies. So not only the systems hardening, but the network segmentation comes with it, with a single tool. But that's basically the value add for the user. You don't have to rely on multiple toolings and for one to do system hardening, another to do release permissive policies, zero trust security, and for network segmentation.
Excellent. So, I mean, I know the rest of your slides deal with just, the benefit of, defining your policies and rules with AccuKnox. But I know that you had a little bit about the continuous integration, continuous development, the DevOps integration. Do you want to talk about that for a few seconds?
Absolutely. One of the goals of enterprise version is to automate the whole least permissive policy settings, right? So the discovery engine that is mentioned here is the enterprise version of the story. The KubeArmor here is out there in open source. So the discovery engine is essentially the one which is actually churning the telemetry data that is emitting out from KubeArmor, and then auto discovering the security portion that is then enforceable. That is the example that I've shown in the AccuKnox dashboards as well. Like I said, getting a view across application updates. For example, you have application 1.0 and then application 1.1. What changed in application 1.1? These are the additional accesses that are now enabled. These are the additional processes that are now getting forked. These are the additional network connections that are getting executed. All of these is something that an application developer themselves might be interested in, or the DevSecOps might be interested in, because they would want to question, why is this happening additionally? Why is this process getting forked, or why is this network communication attempted? So this becomes a tool for a meaningful conversation between developers and the DevSecOps team.
Very cool. All right. Well, I think that kind of wraps us up. But I think you've got the idea that you can put this in many kind of deployment modes. It's well, I won't steal your thunder, please.
So we started off with Kubernetes native architecture, but then very soon realized that most of our users are asking this to be used in the context of pure containerized workloads, which is not necessarily orchestrated, and even on virtual machines and bare metal. So eventually, in later versions, we started adding those extensions as well. Today, KubeArmor can be deployed not only in Kubernetes native workloads, but containerized workloads as well. Not only in the x86 platform, but ARM platform as well. So you have Raspberry Pi. It can be deployed with KubeArmor. So the primary reason why we went that route is because we were working with some of the edge providers and edge solutions providers, and they required something to work on the ARM platform, and they had this huge problem as to how do you protect the edge at runtime, right? So edge is extremely risky to be deployed on, because it's out there in the open. So it has much more attack surface than the cloud native reports. So that was one of the pain point that we addressed in the later versions. Yeah, so this is the edge workloads. This is one of the work that we have done. KubeArmor has done in the context of Open Horizon. You see, Open Horizon has edge workloads, which are deployed as Docker containers, and there could be multiple Docker containers here. The primary aim for KubeArmor was that even if there is a security gap or security exploit available in one of the workloads, that exploit should not be leveraged to jump into other workloads. So that was one of the requirements for the open horizons.
One of the things I love about the pandemic is, the silver lining it is you get to see pets and family and stuff like that. So you should have introduced them, made them, get them embarrassed and whatnot. But, do you see how good he is? He can protect your Kubernetes and take care of his kids getting their stuff. So.
Right. Thank you. I mean that's about it. That's the primary point for KubeArmor and AccuKnox. Runtime security has been our bailiwick. That has been our beachhead. That is where we saw a lot of value needs to be added. The static security is static security also has important aspects to be covered, but we feel that is a solved problem in the sense that there are a lot of open sources available. You need to still have an overall framework or enterprise solution which can deal with both static and runtime security, and that's what the AccuKnox enterprise solution is doing.
Excellent. All right. Well, I think you have some resources for us too, and we'll share those when we post the video as well. It'll be down below. Awesome. Your next slide, I think, is the resources, isn't it?
Yes. There's some of the references. Yeah.
Wonderful. So we'll put those in the chat. So Rahul, it's been a pleasure. I think if you can go to the last slide where you can just wrap it up. So again, my name's Cam. I'm with Dido. If you have any particular questions or anything like that, you can email askKAM@ditoweb.com. We're always looking to help answer your cybersecurity questions. If you have a use case with AccuKnox that you want to talk about or whatnot, or let us use it in a live demo, we'd love to hear about it. And I am sorry, I do have a cold, so if they're snorting like a water buffalo or anything on the recording, that is from me, not from Rahul. So Rahul, thank you for joining us today. Anything you want to leave the audience with?
Thank you very much for having me, Kevin, and it was a great pleasure interacting with you. Looking forward for any questions from the community. Thank you.
Excellent. All right, everybody, have a nice day.
Thank you.